Last episode, we built a fleet, a whole row of servers with a waiter at the door, ready for millions. Then a new box shows up. A payment partner wants to plug in, and it starts talking to our fleet. And nothing works because nobody agreed on how to talk. That agreement has a name, and today we finally meet it, the API. Here's the thing nobody tells beginners. Computers don't magically understand each other, ever. If my service sends the order total in a field called amount, and your service expects a field called total, the message just bounces. Nothing crashes dramatically, it simply doesn't work. Worse, say both sides finally agree, and then one team quietly renames a field on a Tuesday afternoon. Every single service, depending on that shape, breaks at once and nobody knows why. What these machines need is something restaurants figured out ages ago. Walk into any busy restaurant kitchen and look at what's clipped above the counter. Order slips. Every slip has the same shape. Table number here, dish here, quantity here. Any chef can pick it up and cook from it, morning shift, night shift, someone hired yesterday, because the form never changes, even when the people do. That slip is a contract, and that's exactly what an API is. An agreed fixed shape for asking, and an agreed fixed shape for answering. As long as both sides honor the shape, the kitchen can swap chefs, rearrange everything inside, and the waiter never knows the difference. The most common contract style on the internet is called REST, and its big idea is beautifully simple. Organize everything as things, then act on them with a tiny set of verbs. In REST, everything gets an address. All the orders live at /orders, and order number 42 lives at /orders/42. Nouns, not actions. You never see /getorder or /makeorder. The actions come from the verbs you already met in episode 2. Get reads a thing, post creates one, put updates it, delete removes it. So get /orders/42 literally reads as fetch me order. 42, the whole request is a sentence, verb plus noun, and any developer on earth can read it. The response side of the contract you've already met too. Status codes from episode 2. 200, here it is. 404, no such thing. 500, the kitchen's on fire. But here's the REST rule that ties this whole series together. Every request stands completely alone. The server remembers nothing about your last request. Each one carries everything needed to answer it. That's called being stateless. And wait, we've heard that word before. Last episode, the load balancer taught us to keep servers stateless, so any server can handle any user. REST isn't stateless by accident. It's stateless so that a fleet behind a load balancer just works. The pieces are starting to click together. Now a contract only works if it doesn't change under your feet, but software has to change. So how do you evolve an API without burning every app that depends on it? Millions of phones out there are running last year's app, all speaking version 1 of your contract. Change your internals all you like, the contract holds. But rename a field and every one of those phones breaks in the same second. So you don't break version 1, you publish version 2 alongside it. New apps use the new shape. Old apps keep working, and you retire V1 only when it's finally empty. Boring, careful, and it's what keeps the internet standing. REST has an older sibling, and you will still meet it anywhere serious money moves. SOAP. Where REST is casual, light little JSON messages. SOAP wraps every message in a strict XML envelope, with a header, a body, rules for everything. Same information 4 times the wrapping. And the contract isn't a friendly convention, it's a formal document called a WSDL that machines can check like a legal agreement. That strictness is exactly why banks, insurance systems, and old enterprise software still speak SOAP. When money moves, you want a contract a machine can enforce, not a vibe. Everywhere else, lighter won. REST took the internet. The third style skips the whole nouns and verbs ceremony. RPC remote procedure call says, what if calling another machine just felt like calling a function? Your code says get order of 42, like any normal function sitting in the same file. But under the hood, that call is packaged up, shipped across the network, executed on a completely different machine. And the answer is shipped back. Your code never feels the distance. It's the network wearing a very convincing disguise. And the modern version of this idea is fast, seriously fast. The version you'll actually meet in modern systems is gRPC. Google's take on RPC, and its superpower is what it sends on the wire. REST sends JSON, text, readable, lovely for humans but bulky. gRPC sends protobuf, a binary format, unreadable to you and me, tiny and instant for machines. Same data, a fraction of the size, parsed in a fraction of the time, which is why gRPC lives inside systems, service talking to service, millions of calls a second, where nobody needs to read the messages and every byte counts. Public face REST, internal chatter, gRPC. That's the modern default. Style number 4 exists because of a very specific pain, and if you've ever built a mobile app, you've felt it. Your app needs exactly 3 things: a name, a photo, a rating, but the REST endpoint returns everything it knows about the user, because that's the fixed shape of the contract. 30 fields downloaded, 3 used. On mobile data, on a slow network multiplied by every screen, that waste is real money and real seconds. It's called overfetching. And its evil twin, underfetching, when one endpoint isn't enough. So your app makes 3 calls and stitches them together. There has to be a middle path. GraphQL's answer, flip who decides the shape. The client writes down exactly what it wants and gets exactly that back. One endpoint. The app sends a little shopping list, name, photo, rating. And the response is shaped exactly like the ask. Nothing extra, nothing missing, one round trip. The query is the contract, written fresh every time. The cost, since every query can be different, caching gets harder and a badly written query can ask for the whole world in one go. So the server has to defend itself. Power for the client, work for the server. Facebook built it, mobile apps love it, and now you know exactly why. Now for the style that breaks the pattern entirely. Everything so far, REST, SOAP, RPC, GraphQL is ask and answer. You ask, it answers, done. But watch what happens to live delivery tracking. Your food's on the way and the app wants the scooter's location as it moves. With request response, the app has to keep asking. Anything new, every couple of seconds, forever. 300 requests, 9 useful answers. It's like phoning the restaurant every 30 seconds to ask where your order is. Exhausting for you, exhausting for them. What if instead of asking again and again, the server could simply speak up the moment something changes? That's a WebSocket. Instead of a new request every time, the client and server open one connection and keep it open, both ways. Now the server pushes the scooter's location the instant it moves, no asking. And the client can send things up the same way anytime. A phone line that stays off the hook. It's how live cricket scores tick without you refreshing. How chat messages arrive the moment they're sent. How that scooter glides across your screen. Notice the price though. That open connection is state, a hell line the server must remember. The exact thing REST refused to do. Nothing's free, you trade simplicity for immediacy. One more piece and the picture's complete. Every contract so far assumed the server just answers anyone. It shouldn't. An open API with no identity check is a door. With no lock, anyone can read your orders, or worse, place them. So every serious request carries identity, an API key, or a signed token, like a stamp on the order slip saying who filled it in. The server checks it at the door before doing any work. And the contract even has status codes ready for this. 401, I don't know you. 403, I know you, but you're not allowed. Identity first, work second. So, 5 ways for machines to talk. Let's put them on one board because seeing them together is what makes the choice obvious. REST, simple, readable everywhere. The default for public APIs. SOAP, heavy and formal, still guarding banks and old enterprise halls. gRPC, tiny, binary, blazing, the language your microservices speak to each other. GraphQL, the client asks for exactly what it needs, perfect for apps counting every byte. And WebSockets, the open line, for anything that must feel live. Here's the real answer to which API style is best. A real app uses several at once, each where it wins. Look at Dabba. The app on your phone talks REST to the fleet, public, simple, version. Inside, the order service, payment service, and delivery service chatter over gRPC. Millions of tiny fast calls. Your live tracking rides a WebSocket, one open line, pushing the scooters every move. And at the money boundary, talking to the bank, a strict, formal SOAP contract. Because that's what the bank speaks and money likes strictness. 4 contract styles in one app, and none of them are fighting, each one's just doing the job it's best at. That's what it depends actually looks like. So, let's fold it back up. An API is a contract and a grid shape for asking and answering, like an order slip any chef can read. REST for the open web, SOAP for the strict stuff, gRPC for the internal chatter, GraphQL for choosy clients, WebSockets for live. And keep 3 little questions in your pocket. Because all these doors need one gatekeeper, crowds will rush them, and payments must never double fire. Every one of those is its own episode. Coming. But notice something about every single call we made today. Get an order, it's read from somewhere. Place an order, it's written somewhere. Every contract, every style, every call ends its journey at the same quiet box in the corner, the database. And as Dabba grows, that one box is about to become the most stressed thing in the whole system. Next episode, databases. SQL versus NoSQL without the holy war.